Hello everyone, this is Dr. Rajesh and I am again with you with my new video lecture, and in this video lecture we will study a program to multiply two matrices. So in this we will be multiplying two matrices. So firstly I am going to save this program as firstly make it as a habit to save the program first. So I am going to save what multiplication of matrix. Okay, so now I am going to add header file, next header file, these are library functions. Now going to start the main program. Now this will be using array. So I will be declaring the array for first matrix, say two-dimensional array. Say I have declared it of 10 by 10 order, and B is also 10 by 10 order, and multiplication matrix is also 10 by, that will hold the product of two matrices. Now we will define some indexing variables, three indexing variables, and first say this matrix A has order m, so I will define m by n first. Second order is P and Q. So these are the orders. Now one along with that I will also be defining an indicator sum used to sum the elements. Now firstly printf, the user will be asked to enter the values, enter the order of matrix A, new line. So that order will be entered and then it will be scanned by the compiler. The order will be first m, then n, and it is scanning. So here will be ampersand, here will be ampersand. So order has been scanned. Now next I am going to just scan the matrix A. So for this, for loop I is equal to 0, I less than m, I plus plus. So this will be again for, because it has rows and columns. So this will be j is equal to 0. J is the indexing variable. So j so this we have done. We have now have to ask the user enter the values of A, and here is I, %d, %d, and this will be I, j. So this value will be scan f by the compiler, and here will be A here will be percent %d, this will be ampersand a, I, j. So that value has been scanned. The matrix has been scanned. Matrix A has been scanned. So now it will again ask the order for the matrix B. Enter the order of matrix B, new line. So that order will be scanned, say percent D, and order is P and Q, so it will be with ampersand P, ampersand Q. So the order has been scanned. Now if we will use this statement, if n is not equal to P, then I am going to write in this if statement matrix multiplication is not possible, because this n was the number of columns in first matrix and this is the number of rows in second matrix. So for multiplication these should be equal, and if those are not equal then the matrix multiplication is not possible. So else you will just that will now scan the values of matrix B. So for this I am copying this portion as such and will make the necessary changes. Copy, and I will, because this code is almost same, I will paste it over here. So this will be a tab. I am giving the tab, this is the tab, this is the tab, this is the tab, this is the tab. Now here is matrix is B, so its order is P, its order is Q. Indexing variable does not make any difference, they will be same because their job is to iterate in the loop only. Enter the values of, here will be B and it will be IJ, and here will be B. So the matrix B has been scanned, so I am going to remove from here A. So this has been scanned. So now next is we will multiply the matrices. For that we will be needing 3 for loops. So 2 I am copying from here, and will be pasting over here. So first we'll run from I is equal to order is PQ, okay, so it will be P. Second will be first is order, first A's order is M, okay, like in A the order was M and N. So now first is M, then it will be the column of second matrix, it is Q, so that is right. So we will be using, and that closed, that curly brace is closed. So now next we will be using another for loop, and that will be corresponding to K equal to 0 and K less than MN PQ. Both N and P are equal, so here we could use either N or P, so whatever we want we could use. So I am going to use here P, and it will be K plus plus. So this will be sum plus is equal to sum is equal to, it can be sum equal to, in short notation it could be something like that, equal to A star B, and here will be P, here will be indexing variable is I, and second loop is J, and here will be K, here will be K. So this is the logic. So I will be also making another video to clear its logic. So next will be multiplication. Mult is, this is say I J is equal to sum, is assigned the sum. So next we again initialize sum equal to 0. Now the matrix multiplication logic is, this is the, if I mention here, this is the matrix multiplication code. So this is matrix multiplication code. So now we will print the matrix. For that I will be needing the to print two loops, so I am going to copy it from here, paste. So these are the two nested loops, for loops. So resultant matrix will be order M and Q, so that is right. So I am going to just close this one and close this loop. So inside I'm going to print %d I J. So that will be printed, and with every element printed I am going to give here tab, and outside one loop here I am going to give the new line, this is the new line that I am going to enter. Okay, so this is else corresponding. So here I am going to use get ch and return the value of the main program. I am going to use the clear screen also, screen. So this we have made. So let me just compile it. It has two errors. First is missing statement. So here we forgot to put this one, so it's okay. Now let me enter the order. I'm going to enter order in both the cases 2 by 3 and 2 by 3, so that we can see whether it runs fine or not. 2 3. Now it is asking for the elements. I'm going to enter 1 1 1 1 1 1 1. Now it is asking for the elements, asking for the order. Again I am putting 2 by 3. Matrix multiplication is not possible because a number of column in first matrix is not equal to number of rows in second matrix. Now one case we will study of 3 by 3 matrix. 3 by 3 matrix. I'm going to enter 1 1 1 1 1 1 1 1 1 1 1 1. So again it's order 3 by 3. I'm going to enter 2 2 2 2 2 2 2 2 2, and result is this one. So this is the product of two matrices, that how we can do. So this is the program, and it is very easy, and in the next video lecture I will try to explain the logic, and if it is clear for you, then this program is self-sufficient. And if you still need me to just make another video lecture so as I could explain the logic behind it, I will explain. So this is all I have from this lecture. This is Dr. Rajesh saying goodbye, take care, bye bye. Thank you very much. Thank you for watching, and if you like the video, please like, subscribe, share and comment. Thanks.